Okay, so welcome back once again, guys. Now, in this lecture, I'll be talking about a type of a probability. So, we have seen a definition of the probability in a previous lecture. Now, in this lecture, I'll be talking about three different types of the probability that in general you are going to observe. So, let's try to talk about it. Let me share my screen. And here, like I said, so I'm going to talk about types of probability. Yeah. So in general, so whenever we are going to talk about a type of probability, so the very first type which comes in my mind is a classical probability. Classical probability. The second type which comes in my mind is called as empirical probability. Empirical probability. And the third one which comes in my mind is called as axiomatic probability. Yeah. So axiomatic probability. Now, one by one, let's try to understand, even with respect to example and a definition, that what kind of a probability falls under a classical, what kind of a probability technically falls under a empirical, and what kind of a probability technically falls under a axiomatic. Yeah, axiomatic. So here, if I'm going to take a very first example, so let me take this one. So let's suppose if I'm going to talk about classical, right? Let me increase the width of my pen. So let's suppose if I'm talking about classical probability. So what kind of a probability is called as classical probability, by the way? So classical probability is also called as a theoretical probability. So basically this classical probability will be used when all the outcomes are known and equally likely. So formula wise, I have already written this formula in my previous lecture, but let me write down again. So for a particular event, if we are trying to find out the probability, so number of favorable outcome, number of favorables outcomes divided by total number of possible outcomes. So this is something called as classical probability formula, and obviously ranges is going to be in between 0 to 1. But let's try to understand it with the help of a particular example. So let's suppose we are going to roll a dice. So we all play a Ludo, I believe. At least we all have played at some point of a time, even in our childhood. Nowadays we are playing that Ludo maybe with the help of app, by the way. So if I'm going to, so example number one says that if I'm going to roll a die, right? Roll a die. So die will be having a 6 faces, means a possible outcome could be 1, 2, 3, 4, 5 and 6. So these are my possible outcome. This is something which I can assume that, okay, fine. So there is a possible outcome. Now, if someone is asking me that what is a probability of getting 3? Yes, what is the probability of getting 3? So 3, what is the probability of getting 3? So obviously here, if I'm going to apply this formula, so number of favorable outcome is going to be 1 because 3 can appear only one times, divided by a total number of the possible outcome, which is technically 6. So this is going to be the probability of getting 3 if we are going to roll a die. Now, similarly, so if I'm going to toss a coin, so we all know that with respect to a coin, there will be a head and there will be a tail, right? There will be a head and there will be a tail. Now, if someone is asking me a question that what is a probability of getting head? So there will be head or there will be a tail, right? These are the only two outcomes that you can expect, not a hung one, by the way, where you can get head and tail both. So here, what is the probability of getting head? So obviously this is going to be 1 by 2. It's a 50% chance that you are going to get a head. Similarly, so I can try to give you maybe a example number 3 over here. So let's suppose if I'm trying to play a card, right? If I'm trying to play a card. Now, what is a probability that you will end up drawing a king? So what is a probability that you will end up drawing a king? So we all know that there will be 52 cards, right? There will be 52 cards in total. and out of those 52 cards, 4 will be basically king, right? 4 will be basically king. So what is a probability of getting king out of this 52 cards? So it's going to be 4 by 52, I can say, or technically after like doing a calculation, so it's going to be 1 by 13. So this is a probability of getting a card. Now all of these calculation I am able to do it with the help of this particular formula which I have written, a number of favorable outcome divided by a total number of the possible outcome. As simple as that. Now, whenever you are trying to do this kind of a mathematical like a application, or whenever you are trying to find out the probability in this way, so it always falls under which category? It always falls under a classical category. Now, so as I have mentioned, a second one, empirical. So what kind of a probability falls under empirical? Let's try to understand that particular part. So here, a second kind of a probability, which I have already mentioned, is called as empirical. Empirical. In other words, it's also called as experimental. Experimental probability. Yeah. So now what kind of a things falls under this empirical or experimental probability, and what is a formula for this one? So again, probability for any event is going to be a number of times event occurred divided by a total number of trials. Now you will not be able to find out a lot of differences between this one and the previous one, basically, right? So it's almost same, but yeah. So it's labeled as an experimental one, where we try to do a lot of trials, and then out of that we try to find out that, okay, fine, so what is a possibility that this is going to happen, or maybe that is going to happen at the end of the day. For example, so let's suppose if we are receiving thousands of email, yeah, thousands of email. Now out of that, 400 was basically a spam, right? 400 was technically a spam. So basically we have done a experimentation, and I'm just trying to do experimentation, let's suppose with respect to my mails. So out of my 1000 mails, I was able to find out that 400 was basically a spam. Now if someone is going to ask me a question that, tell me what was a probability is P, what was a probability of your spam? So probability of spam is going to be simple, 400 divided by 1000 is going to be 0.4. So this is the probability that whenever I'm going to receive a next email, so maybe that is going to be a spam. This is the 40% chance that, okay, fine, so this is going to be the spam at the end of the day. Now, so if let's talk about example number 2 with respect to this empirical one or the experimental one, right? So here, let's suppose there were 200 students. There were 200 students, and out of 200 students, 180 students has basically passed the exam. Now, if someone is going to ask me that what is the probability that you will be able to pass the exam? So simple, you will be able to pass the exam. So it's going to be 180 divided by 200. It's going to be 0.9. So there is a 90% chance, or there is a probability wise 0.9 is the probability that, okay, I will be able to pass the exam based on the track record of a 200 trials or 200 students that we have observed, by the way. Yeah. So 200 things that we have observed, by the way. Now, so example number 3, I would like to give you again, which is similar to the previous one, not a very different one. So let's suppose there is a company who is making some products. So let's suppose they have made a 10,000 unit of a product. So 10,000 unit of the product, and out of that 50 product was basically defective. Yeah, 50 product was basically defective. Now, if I'm going to pick any of this product out of random, right? So what is the probability that that product could be a defective one? So here 50, which was a defective, divided by total number of the trial that we have done, it's going to be 0.005. So this is the probability that if I'm going to pick up any of this product, so it is going to be a defective one. Now, where this kind of a probability, empirical probability, or I can say experimental probability, I will be able to use it. So whenever I'm trying to perform a A/B testing kind of a things, where I'm trying to check my ads, that which is working, which is not working, which is like trying to bring a click-through rate basically, and which is not able to bring it. Let's suppose if I'm trying to solve some sort of a machine learning problem, right, for a real-time data set that I have a data set which is given to me, and based on that, I'm trying to find out a probability of occurrence of some of the event, or maybe an outlier, something like that. So on all of those places, so where you have done an experiment, where you have observed data, yeah, which is already available. So now I'm coming to the differences between this empirical one and the classical one. So in case of classical one, so obviously we were aware about some of the event, and based on that we are trying to find out the probability. Now in case of an empirical one, so we have some of the observed data, or we have a experiment, not just a theory, and based on that we are trying to do some sort of a prediction, or we are trying to find out some of the probability. So that is something called as empirical one, or you can say a experimental probability. Now there is a third kind of a probability you will be able to find out, which is called as axiomatic probability. So let's try to understand what is the meaning of this axiomatic probability. It's a little bit different even in terms of a formula. So axiomatic probability, right? So what does this means? So basically this axiomatic probability was introduced by Andrei Kolmogorov basically. So he was a mathematician, and it was in basically like introduced by Andrei Kolmogorov, and he has given three rules. So it is also called as rule-based probability. So three rules, or you can say he has given three axioms, by the way. Three axioms, or in other word you can say he has given three rules, so that I will be able to find out a probability, and I will be able to like find out a probability for some of the events. So what was a rule which was given by Andrei Kolmogorov? So the axiom number one, or you can say a rule number one. So let's suppose if I'm going to talk about the axiom number one, or a rule number one over here. So it says that probability of occurrence of any event should always be greater than 0. This is what he said, that probability of any event. What this statement says, that probability of any event, if you are trying to find out, so it's always going to be a non-negative, means greater than equal to 0 at any point of a time, and which is true, right? Which is true, by the way. So this was a rule number one. Now he has given axiom 2, or rule number 2, and it says that P of S is equals to 1. Now what is the meaning of this? So he said that the total probability of any sample space is going to be 1. We know that okay, so for any kind of event we are going to consider in this entire world, probability is going to be for the entire event. So for example, if I'm trying to roll a dice, now someone is going to ask me that what is the probability that I will be able to get 1, 2, 3, 4, 5, 6. So in that case, 1 by 6, 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 6 times we are going to do the addition, and technically it is going to be 1, right, for the entire sample space if I'm going to calculate. So this was the rule number 2, and he said that total probability of any sample space is going to be 1. Again, a very simple rule that he has given. Now coming to the third part, which is basically axiom 3 over here, and he said that, or he has given a formula, A union B is equals to probability of A plus probability of a B. Now what is a meaning of this particular formula? So basically this formula is been used for or this is called as additive formula for a disjoint event or mutually exclusive event, independent event. So let's suppose I have two events, so event A and event B. So if I have to find out the probability of event A and event B, if events are mutually exclusive or disjoint, there is no connection in a layman term. So there is no connection, that how we'll be able to find out the probability. So this is the formula which is going to give me the probability about that one. Now let me give you an example, and with the help of example, let's try to find out this one. Let's try to establish this one. So here example number 1, I would like to give you with respect to a simple coin operation. So let's suppose if I'm going to toss a coin, right? If I'm going to toss a coin. So let's suppose we have A. So A is nothing but event of getting head, and B is nothing but event of getting tail. Yeah, probability. So what is a probability? Because these two events are independent events. It's not like when head is occurring, tail will occur, or tail is occurring, or head will occur. No, not like that, right? So what is a probability of a tail and a head together? So it's nothing but probability of head plus probability of a tail. We know that probability of head is 1 by 2, probability of tail is 1 by 2, so it's technically going to be 1. So this is the total probability for this one, where events A and event B is mutually exclusive, independent event that we are talking about. Yeah, a mutually exclusive event or disjoint event which I am talking about. Yeah. Now, so example number 2, that was a very simple example. So let's talk about example number 2, drawing a card. So let's suppose there is an event A which is trying to represent event of drawing king. Event of, let's suppose I'm writing king over here. Fine. So what is a probability of drawing a king, by the way? So it's going to be 4 by 52. As we all know, there will be 4 king card and then there will be a 52 total number of cards. So what is the probability of this drawing a king? Let's suppose I'm labeling it as a event A. So it is going to be 4 by 52. And let's suppose there is a event B. So event of, maybe I can say queen, right? So what is the probability of drawing a queen? So again, there will be 4 queen card divided by 52. Yes, 52. Now, so if I have to find out a probability combined for this event, so it is going to be probability of A plus probability of B. So it's going to be 4 by 52 and 4 by 52 over here, which is going to be 8 by 52. Eventually it's going to be 2 by 13, right? So here I'm able to find out that for event of king and event of queen, what will be the combined probability. And both of this event of getting queen and event of getting king, is a complete disjoint event that I'm talking about. Yeah, that I'm talking about. Okay. Now, so let's suppose I'm going to give you example number 3 and example of a dice. So here, let's suppose I have an event A. So rolling or getting, let's suppose getting 1, and event B getting 6. Now, what is the combined probability of A and B event? So it's going to be 1 by 6 plus 1 by 6, because probability of getting 1 is 1 by 6, probability of getting 6 is also 1 by 6. So it's going to be 2 by 6, sorry, 2 by 6. It's technically going to be 1 by 3. So this is something that you all will be able to find out at the end of the day. So here we talked about a 3 kind of probability. So basically a classical probability, which is technically called as a theoretical probability. Empirical means experimental one, where we have a data set, right? And then we have talked about a axiomatic probability. So where we talked about 3 rules, right? Where we talked about the 3 rules, and based on that, we try to find out a probability of occurrence of A and B, A union B, by the way. Yeah, A union B, and that is going to be probability of occurrence of A plus probability of occurrence of B. So hope all of you are able to understand this 3 different kind of a probability: classical, empirical, and axiomatic. With that, thank you so much, everyone. Take care, and see you again in my upcoming lecture.